Hi, it's me Zubairuddin Bhatt from Group 324. My topic is topic number 11.4, that's ionic channels, the above described model of the generation of the impulse or phenomenologically and do not disclose the molecular mechanism involved. But how we are the ions transport across the axon membrane or the transported by means of special carriers through channels in the membrane. Experiment solves the alternative in favor of the channels. In the absence of permanent sodium and potassium ions, the high frequency conductance of the membrane is equivalent to zero. If some mobile charged groups functioned in the membrane, there must have been observed an electrical current membrane. There must be having observed electrical current. It's possible to estimate the quantitative characteristics of the channel, the number of which per 1 micrometer square of the membrane surface is several hundred. The conductance of signal sodium channel is 4 into 10 raised power minus 12 mho, and that the signal potassium channel is 12 into 10 raised power minus 12 mho. The conductance permeability of the first channel is about 10 power 7 ions per second, and that on the later that's about 10 to the power of 6 ions. Nonetheless, it is difficult to say what the channel is the structural sense. An ionic channel may be locked upon as a sort of vectorial such as enzymes, that's lipoprotein complexes experiencing conformational arrangements regulated by an electrical field. The sodium channel is the tightly sealed by one molecule tetrodotoxin, the toxic principle of the Japanese fish fuga or saketoxin, the dinoflagellate of red tides. Accordingly, these poisons paralyze nerve conduction. The use of these substances had made it possible to determine the manners of channels per unit surface area of the membrane into steady and gating current. Hodgkins and Hockley have established the exponential relationship between the initial change of the membrane potential, that's phi, and the peak value of GNA to the change of phi by 4 to 6 millivolt to the side of depolarization. There corresponding an e-fold increase in GNA. One might think that the change is the result of the action of the electrical field on the disposition of some ions in the channel. Considering that the conductance GNA is proportional to the fraction of these ions displaced by the field, we obtain that GNA is equivalent to GNA maximum divided by 1 plus B of experiment minus Z alpha phi by RT. That's equation number 11.31, where Z is the velocity of the hypothetical ion, alpha is the number where expressed the fraction of voltage, phi that acts on the ion, B is the factor which is independent of voltage, phi that acts on the ion, B is a factor which is independent on the phi. The average experimental value of Z alpha is equivalent to 3.5 according to available data. Hodgkins and Hewlett's preassumed that such hypothetical ions determine the activation and inactivation of sodium and potassium channels. Admittedly, these are calcium ions. Indeed, the change in the concentration of calcium ions has strongly effect on the excitability of nerve and muscle cells. A theoretical model has been worked out which account for the shape of the curve of GNA. A calcium complex with calcium 2 positive, and in a state B it contributes the passage of sodium ion through the channel. The model corresponds to the following scheme: A plus calcium is equivalent to calcium 2 plus A gives calcium 2 plus B. The solution of the corresponding kinetic equation yield. Thus, the sodium ions were expelled from the external solution. The conductance of the channel was suppressed by tetrodotoxin in order to average large fluctuation, as was made of a strong element. The experiment was as follows: a positive regular pulse was applied for a fiber that had been preliminarily hyperpolarized to 90 or minus 100 millivolt. At the start and finish of the pulse, there were observed transient current direct to the exterior and interior of the axon. Thank you. This is all from my side.